Hey guys, I'm Pat Kelly. Okay, in this problem, they give us a differential equation. I know, real shocker there, right? But the directions say to use the method of variation of parameters. So I'll walk you through that. You can see this is something we'll end up using, but I'm a little ahead of myself. This is actually just a system of equations that we use for that method, the variation of parameters. And don't let it look too ugly to you. It's actually a really good thing that we have this, because this is going to guide us through the work that we need. Before we get there, though, the way that I would start, the way you really need to always start, is to go to your differential equation and first find the solution to what would have been the homogeneous version of this. Okay, so I'd be looking at the y double prime plus y equals 0, right? And that's just for the homogeneous version of this. So then I'd probably get into my characteristic equation, and I'd be looking at m squared plus 1 equals 0. So m equals plus or minus I, right? Subtract over the 1, square root, I get the negatives under the radical. Okay. Then you have to remember how to interpret your solutions to the characteristic equation with the complex numbers, specifically the imaginary part of that. What that tells me is that my y sub h will equal c1 cosine of just x, because the imaginary part of this has a coefficient of 1, so I just get a 1 inside the cosine. The coefficient outside of cosine is 1, because that would have been the real part, a plus bi, that looks familiar, plus c2 sine of just x. Okay, good. So you always start by finding the solution to the homogeneous version, and from that we try to represent our particular solution. Okay, so let me switch colors here. Our y sub p, I'd like to slip right below here, whoops, y sub p. And this method of the variation of parameters, it's different than our undetermined coefficient method, because that capital F of x is not something well behaved. If it's a polynomial or something with sines, cosines, or an exponential, then it'll behave well with that method of undetermined coefficients. But since our capital F of x is something different, that's all I need to worry about, that's when I look to this variation of parameters method. And with this system of equations, you can see what you need are these u's, u1 and u2. And I know there's a y1 and a y2 in there, but you're actually familiar with those already. If you don't remember, I'll remind you in a minute. But in order to get those u's, the u1 and the u2, where those come from is that our y sub p is actually like a twist or a spin off of the y sub h. What we do is we replace those constant coefficients with functions. Right? I don't know what they are yet. In fact, I have to figure them out. But I represent them here as u sub 1, just for my first term, cosine of x, plus u sub 2 times my sine of x. Okay? So those u's are actually functions of x, expressions that may involve x. Right? So there's your u1 and your u2. You can start to see this shaping up in our system of equations, my u prime, u2 prime. And y1 and y2, when I said that you know what those are your components of the homogeneous solution. Right? So here's my y1, and here's my y2. Okay? So that's why I was suggesting that it's actually a good thing that we have this system of equations as like a template to follow, because this is going to guide you through your work. Let's get going on it now by trying to write this system with our specifics. First is u sub 1 prime, and I don't know that. That's going to be the goal of my work, is to find u sub 1 and u sub 2. So for now, I just write it as u sub 1 prime. But my y sub 1 is just that cosine of x. Okay, plus u sub 2 prime. I don't know what that is yet, but y sub 2 I know is my sine of x. And I know that that's going to be equal 0 in this first equation. In my second equation, u sub 1 prime, and y sub 1 prime is the derivative of this guy here, so I'll use parentheses because of that minus. I don't want to lose it. But the derivative of cosine of x is minus sine of x. Plus, still trying to follow my template, u sub 2 prime times the derivative of my y sub 2, which is sine of x, and the derivative is cosine of x, equals capital F of x, which is the right-hand side of our original differential equation. So secant of x. All right. Now, I uttered these words several times. This is a system of equations. Not a system of linear equations, but still a system of equations. And the key there is that you can use one to solve the other. Let me say that differently. Is you use a multiple of one to combine with the other in order to solve for our unknowns of u1 and u2. So let's go with that. What I'm going to do is, again, I'm thinking system of equations. What I would typically do is try to get the coefficients of matching terms to be the same so I can add them together. So I'm thinking that I'm going to focus on this cosine of x. I need it to be a sine of x, because then when I add it to this one right below, that term will drop out. So I'm going to multiply, let me slide over here and show you my work. I'm going to multiply that first equation, multiply by tangent of x. Make sure that makes sense to you. Tangent is sine over cosine. So when you multiply here, the cosines are going to cancel out, and you'll be left with a sine, which is going to combine with that and blank out to 0. Okay, that's why I did that. So let's come over here and multiply. If I multiply by tan of x, as we already mentioned, that's going to be u1 prime times just sine of x. Okay? Plus, I have to multiply the whole equation by tangent. So now I'm looking at, I still want to see tangent as sine over cosine. So let's write this as u2 prime sine squared of x divided by cosine of x. Again, that's just sine of x being multiplied by sine of x over cosine of x. Multiply the other side, which is just 0, so that's not a problem. And I did that because now I can take these two equations and add them together. And if I add them together, the first two terms cancel each other. That's what we were shooting for. And these two terms are going to have my u sub 2 prime. Let me do a little bit of algebra in my head. If I'm going to add these two, these expressions, I need a common denominator of cosine. So I'm going to have to multiply this guy by cosine of x over cosine of x. So that's going to become cosine squared of x. And I'm adding it to this lower term, which has the numerator of sine squared of x. And that would all be over that common denominator of cosine of x. A little bit of algebra, a little bit of trig. And don't forget your right-hand side of the equal sign, we still add these two guys, so I just get secant of x. I hope none of you panicked and turned off the video here because you saw a lot of trig and a lot of algebra. This is actually behaving very well for us, because look at the numerator. Cosine squared plus sine squared is always 1, so you've got 1 over cosine, better known as secant. So the secants divide out, and your u2 prime equals 1. See, actually simplified quite a bit. All right, now what? I use that u sub 2 prime that I now know of equaling 1 up, your choice, but I'm going to pick this top equation, and we're going to use it to figure out what u sub 1 prime is. Okay, so let's take a look at this equation. I don't know, I'll switch to the orange again if it helps. But from here, I'm looking at u sub 1 prime times cosine of x This u sub 2 prime is just 1, so you're going to get plus sine of x equaling 0. Sorry it's crowded, but the different colors hopefully helps. Remember, we're trying to solve for u sub 1 prime, so subtract over the sine of x, divide the cosine of x. Can I get away without writing it? Well, I'll write it. Minus sine of x, you divide by cosine of x. I wasn't going to write that. I was going to simplify it on the fly, but let's just simplify now and realize sine over cosine is tangent, so don't forget the minus there. U sub 1 prime equals the minus tangent of x, okay? Whew, that's good, but we need to know what, let's just glance over here, we need to know what u1 and u2 are, not the primes of those. So you integrate. I'll try to even stay consistent with the coloring if I can. U sub 1 prime equaled minus tangent of x, so u sub 1 equals, and what I'm doing is in my head integrating tangent, actually integrating a minus tangent, but the integral of tangent is a negative natural log of cosine. So you actually have a minus, I'll just write it as a positive, natural log of cosine of x, okay? And also, I'll switch to green, my u sub 2 prime equaled 1, so from that I integrate again, a lot easier this time. The integral of 1 is just x. Whew. So you've got your u1, you've got your, sorry, did you catch that? Were you yelling at me? That's supposed to be a 2 from here. You've got your u1, you've got your u sub 2. We use those back in here, and we're ready actually for a final answer. So grab this orange. Okay, now you've done enough of these, I hope. You remember that your final answer of y equals the sum of both your y sub h and your y sub p. So I'm going to put all of this together here. C1 cosine of x plus c sub 2 sine of x. Let me slip down just so I don't start straying over there into that work. Plus u sub 1, which we said was the natural log of the absolute value of cosine of x, times cosine of x, and then plus u sub 2, which we said was x, times sine of x. So this is my final answer. I'm going to go one more step, though, and simplify. I'm just thinking, especially if you end up checking the back of the book to see if you got the right answer, we'd probably end up seeing these like terms combined. So here's a cosine, here's a cosine. Let's write that as parentheses, c sub 1 plus the natural log of cosine of x in absolute value bars, all being multiplied by cosine of x. And the two different sine of x's, I would again combine c sub 2 plus x, close parentheses, sine of x. That's my final answer. You got to feel good about yourself getting it, so go do some more on your own. Feel good about yourself with those, okay?